Aurora here with Supercharged Science, homeschool science education and curriculum programs for K through 12. And today we are going to be doing a class on light and lasers and holograms. And honestly, we are going to do this over 2 days because there's a lot of things I wanted to cover, and I'm pretty sure you didn't want to sit there and watch me for 3 hours. So for those of you who are just jumping on, I'll just talk for a second and introduce myself before we get started so everybody can start at the same time. Now, my name is Aurora. I'm with Supercharged Science. We've been doing science curriculum and education since 1999. You believe that's over like 2 decades. And my job is to personally inspire your kids to get excited about science. Now, I went to high school and college at the same time when I was 17 while also working for NASA. I also got my pilot's license when I was 17. 17 was a big year for me. And, and I taught mechanical engineering at Cal Poly State University. And over the years, I'm actually the current president right now of the Central Coast Astronomical Society. So we're going to do stargazing on Saturday, but I'll tell you more about that later. So if we're actually going to do a star party virtually, and so I will walk you step by step on how to do that as well and participate in that. So if you're interested in astronomy and the stars, you'll have a real astronomer showing you how it's done. Okay. So for today, we're going to talk about light and lasers. And for those of you who maybe this is your first time tuning in, I want to extend a special welcome to you. We've actually done a number of things. Like yesterday, we built catapults, and the day before we built rockets, which are somewhere back here. But we did a rocketry class, and so each day we've been doing different things. And so if you've missed any of those, Facebook will automatically archive my Facebook Lives, and you can find those in my video library. And so you can click on those and watch those at any time. I know we've got a number of folks from the UK as well from Australia who are saying this is great, but that's like 2 o'clock in the morning for me, like right now. So don't worry, just take your time and just browse through those when you're done. There's actually about 300 videos, 400 maybe in there. So you'll have plenty to choose from. The ones that are most recent, of course, are the ones that we're doing. So, okay, so we are going to get started. I'm going to get my slides ready. We're going to talk for a little bit. If you've got questions, make sure you put them in the comment section so I can go through those as well. And also, if you know of anybody who has kids at home and they're kind of not sure what to do, invite them to the class like right now. And so I will actually keep your kids excited and engaged, and I will personally teach your kids right now for probably the next 20 to 30 minutes. And after class, I actually have a set of experiments you can do beyond that. So your kids are going to be excited and engaged for this amount of time and even more, probably hours more, because lasers are just really cool. Now, if you've got the materials for class, fantastic. If you have 0 materials, you can still fully participate. I will show you how to do that when we get to the experiment part. So even if you have no materials, please don't panic. Don't freak out. There's already enough of that going on. So all you need to do is just keep up with me and enjoy the class and just really enjoy learning and loving learning. Okay, you guys ready? All right, let me get my slides ready for you. Hang on just a second. Okay, so here we go. And actually, this is a picture from my science camp. You see me, I'm right here. This is a group of about 200 students that are in a dark room. We fogged it up completely and armed all the kids with lasers and put on some 80s music. And yes, there is a rocket hanging from the ceiling. So the kids are actually, believe it or not, they're on task and they're doing their laser assignment and their laser experiments in the dark. And it was totally fun. It was a total blast. So we're going to be doing a bit of what we did with them during that science camp experience. You guys ready? Okay, so the materials that you're going to need are really simple. So this is a 2-part class. So if you've got, actually we're not even going to use all these things. They're very simple. Look, we got pencil, paper. If you got the gummy bears, great. If not, you can just watch me do it. You will need a laser for a laser class. If you don't have one, the dollar store had these for $1 when I was there, and they had hundreds of them. So an old CD and plastic film. We're actually not going to need that till tomorrow. So this used to have salad in it. This is perfect. Or if you have like a berry basket, you just need something smooth, so like a soda bottle. This one you have to take stickers off, but something smooth like a plastic film. We're actually going to do Pepper's Ghost tomorrow and when we make a hologram. Oh, and reminds me, for next week, you're going to need this. No, we're not making s'mores. I just realized that's kind of what it looks like. We're actually going to measure the speed of light using marshmallows and bars of chocolate. And you'll actually get really, really close to the actual published value, which is super cool. All right, so you guys ready to get started? Okay, let's get going. So parents are like, wait a minute, I'm not so sure about these classes. It's in the name of science, right? We got gummy bears. Today I actually asked you to get M&Ms too, didn't I? Okay, so what are we going to be doing? Well, we're going to talk about light. So you tell me right now, type it in the comment box. Anytime I ask you a question, you can just shout back the answer, just like we're having a conversation, just like I could hear you. Just tell me the answer to the question. Ready? Question number 1, what is light? If we're going to study it, I got to know what you already know. Tell me out loud. You can type it in the comment box if you like. What is light? I'll give you 10 seconds. Ready, set, go. Okay, so it's actually a really hard concept to explain directly without using a bunch of big words that are confusing. So let's do it this way. Can you imagine, or just look at the slide I'm showing you, a picture like a candle flame? Okay, and now is that a light source or is it reflecting light? Actually both. The flame itself is a light source, but what about the wax part of the candle? The part that's not on fire, right? The solid part down here. Yep, that is reflecting light, right? Light is hitting it and bouncing into your eyes so you can see it. Great. Now, point to the images and tell me which ones are light sources. You're looking for 4 of them. Go ahead. Do it now. Which ones are light sources? That's right, the campfire, the sun, the bottom half of the bug, and what else? The lightning. Okay, good, good. Okay, now which one is reflecting light? All the rest of them, right? Wrong. The other half of the bug is also reflecting light, isn't it? There. Is my microphone better now? I just got some messages saying that the sound was distorted. Does that sound better? Sorry about that, guys. Okay, the fruit and veggies, the diamond, the moon, they're all reflecting light. What about a mirror? Like when you look through a mirror, or look at a mirror, is that reflecting or is that a light source? Yeah, it's reflecting, right? What about a window? That's a tricky one, huh? Yeah, it's also reflecting light. Okay, good. What about these over here? Light can be generated by lots of different things in different ways, right? Now point to it as I call it out. Point to the one that makes light when the wire inside glows red hot. Yep, the hot stove. What else? The incandescent bulb. Good. Now, which one has the burning gas inside that causes the gas to glow when it gives off heat? Okay, good. Yeah, if you've ever burned your hands on one of these old-fashioned gas lanterns, you're right. Okay, which one is a light source because it mixes different chemicals together and the energy is given off mostly in the chemical reaction due to light? It doesn't get hot usually. Chemical reaction, chemiluminescence, light sticks down here. Good. Now, which one takes energy from electricity, pumps it through a tube of gas, which energizes and electrifies the gas, meaning that the gas suddenly is, normal gas cloud and it's not glowing, but then you pump so much energy into it that the gas gets really excited and the atoms start knocking electrons off each other, and now you've got these naked electrons that are electrifying the gas and starts to glow. Which one? That's right. Neon open sign. Good. Excellent. Oh, yeah, and the fluorescent bulb. Okay, so look around you. Do you have any other sources that I didn't mention in your house right now? Anything else giving off light? Okay, so there's a lot of them, right? There's campfires, which maybe you don't have in your house right now, but okay, good. So, which part of you can detect light? Oh, I'm showing you the answer, aren't I? So, have you ever gone out into the sun and your eyes are closed and you walk out there and you've got bare arms and you can feel the light on, you can tell when you're in the sun versus in the shade? That's because your skin is also a light detector in addition to your eyes. Your skin, though, can detect infrared light, which is invisible to your eyes, but your skin is a really good detector of that. So that's the warmth that you feel. So light basically is energy that can travel through space. Now energy, we talked about this yesterday in our physics class, energy can take one of 2 forms. It's either matter or light, or called electromagnetic radiation. So light is energy that can travel through space. What color is the sun? It's yellow, right? Or is it? Have you ever been in an airplane or looked up at the sun near noon when the least amount of atmosphere, it's like the thinnest that you can look through, and noticed how the sun looks more white than usual? Yeah, that's because the sun is actually white. And looks like we're still having mic distortion problems. So I apologize for that here. I'm turning down my mic even more so you guys so I don't sound terrible. Okay, is that a little better maybe? Okay, so the sun is actually white, right? When you look into space and you look at the sun, when you see pictures from space of their star, it's actually white. Now you already know the answer to this next question. What color makes up white light? Say it out loud. What color? Colors, right? Trick question. Red, orange, yellow, green, blue, purple, or violet, right? Okay, so white light has all the colors, all the wavelengths. Wavelength is another name for color of visible light, and they're all at the same intensity. You ever play with a prism? What does a prism do when you stick it in sunlight? Right, it makes rainbows, right? That's because a prism will take the white light, which is light that appears colorless, like you can't normally see it, but it really has all the colors mixed up inside, and a prism will unmix that light back into its rainbow. And it does that by bending each color just a little more so you can spread it out. So white light is actually an equal mix of all the visible colors. And prisms, they're actually everywhere you look. You don't have to be this triangular cut piece of special glass that you have to pay like 10 bucks for. You can find prisms in transparent marbles, pebbles, even raindrops, drops of water, anything that light can travel through and change speed as it crosses from one to another, like air to glass or air to water. That is a prism. Okay, so the question is, why does it do that? Why does light change speed? How is that possible for you to see color? Okay, so how are we doing so far? You guys with me so far? Okay, I'm sorry about the microphone problems. Is that a little bit better? I know I turned myself down so I wouldn't overmodulate, but I hope it's okay. All right, so here we go. So how does light do that? Okay, so if you have an old CD, you can grab it, go for it. But if not, just look at this picture. So you know that if you turn down the lights, and well, actually you may not know, but if you have an old CD, you can grab it right now, and you can turn down the lights in your space, and then grab, oh, I forgot to grab it, sorry. And so you grab a flashlight like this, and then you can just play the CD in here, and then you'll notice you get these rainbows, and I took a picture of it so you could see it. Turn it, now I'm too low. Okay, hang on. Thank you, everybody that's giving me feedback. Now it's too low. Okay, is that a little better? Yeah, got to work on these microphone issues, don't we? Okay, at least we have audio, right? Could be worse. I could just be sitting here like this and not saying anything. I could have like no audio. Okay, so here we go. So let me show you that slide. So you can turn down the lights, and when you shine a flashlight on it, what do you see? Look at my picture here. What do you see? A diffraction grading is the same thing as a CD, okay? So I put a picture here, just so you don't have to run around and do this right now. You can do this tonight. This is what a candle would look like if you bounced the light off of a CD and looked at it on the wall. Okay, so if you're using a CD, it would look like this. A CD is just like a diffraction grating, which is like thousands and thousands of little tiny prisms all stacked on top of each other. And there's a mirror back there. And so it's the same thing. So diffraction grating has no mirror. A CD is a diffraction grating with a mirror. So same thing. Okay, so you'd see a rainbow, right? So the light is getting split. And the question is why? Okay, so for example, what happens if suppose we're doing an art class and it's painting, and I give you red and yellow and blue. Could you make the rainbow? The answer is yes. If you're a physicist and I give you red light and yellow light and blue light, could you make the rainbow? The answer is no. So if you took all the colors of paint and mixed them together, what do you normally get? You ever seen like a preschooler trying to paint with finger paints, and you give them like all these beautiful rainbow of colors, and what do? They stick the whole mess together, right? And what color do you get? Is it black? No, it's like this muddy brown color, right? Okay, so what happens if you take light and put it together from all different colors? You take red, orange, yellow, green, blue, purple. What do you get? Yeah, you'd actually get white light. Okay, so why does it do that? Well, have you ever seen a harp? You know how they have long strings at one end and like short strings at the other? Okay, so that's probably something that you're familiar with. So the long strings, if I were to pluck them, here I have a picture of this. If I were to pluck the long strings, is it low or is it a high pitch? It's really low, right? Boom, 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 right? That's like red, orange colors. If I pluck the medium strings, that'd be like boom, boom, boom. That would be my yellow and green colors. The high strings over here, the bing, bing, boom, that's blue, violet, and very high, plink, plink, plink. Okay, so now we're getting into the ultraviolet X-rays and gamma rays. So light of a rainbow are like notes on the harp, And as we get to our longer strings, the sound we hear is lower. So the wavelengths are much longer, the color is more red. Red is the color, the wavelength. How much energy light has is determined by what color it is. And this thing is called the electromagnetic spectrum. This is an energy spectrum that tells you over here, long wavelength, lower energy. Over here, high wavelength, like this part of the harp, dee, dee, dee. Very high energy in here. Like if a gamma ray gun is pointed to you, you should probably run, especially if they're, anyway, we'll talk about that later. So the frequencies can change, right? So have you ever gotten an x-ray before or know someone who has, maybe the dentist or they've broken a bone? X-rays are really high energy waves. You won't be able to see them with your eyes, but they're really high notes on a harp. Okay, so let's see, not all light is actually going to give you the same rainbow. So you just can't take any old light, pass it through a prism, you won't get the whole rainbow. White light will give you the whole rainbow, but it depends on the light source itself as to the rainbow it's making. Sometimes you just get like red and green, sometimes you'll get green and yellow, sometimes you'll get a pattern. Here, let me show you some. So if I have hydrogen gas and I electrify it, it starts to glow, and this is the colors that they're putting together. So I'm going to get red, blue, and purple. If I look at a neon open sign with my CD, I'm going to get red and a lot of red and orange and just a little bit of green. If we take a mercury lamp or we take mercury gas and we electrify it, it's going to be just these colors. You see that? Sodium lamps, we're just going to get mostly in the yellow. That's why they look yellow. You know, these are the lamps that used to be the amber lights that you would see. And then notice how strong these things. So that's why old street lights would actually look yellow. Does that make sense so far? How are we doing? I'm going to pause here for a second. How are we doing so far? You guys good? Okay. All right, let me pause here just for a second because we are about to shift gears and do some experiments. You know what? Let me show you a couple more things really quick. Okay, so if white light is all these colors, what about a laser? So I have a laser pointer here. I don't know if you can see it, but there's a little dot on my hand. How many colors is that dot? It's just one color. So if I take this and I shine it on a CD and I project it on the wall, how many colors do you think it would split into? Watch this. Look at this. Laser light is what we call monochromatic. It's one color, right? So you can shine that through a CD or bounce it off of a CD or shine it through a diffraction grading, and you're still only going to get one color. So if you have a CD and you have a laser pointer, you can do that right now. Go ahead and shine it on the CD and shine it like onto the ceiling, something where there isn't a whole lot of other stuff, and tell me how many dots do you see? Do you only see one dot or do you see more than one? Go ahead and do it now. Kind of turn the lights down. You might have to get a little bit close to the wall if you're going to do this right. So do you think you just get one dot or more than one? Go ahead and do it now. I'll give you like 10 seconds. Go ahead. Okay. I know I forgot to tell you to get a CD. I'm sorry. Don't worry. You'll be able to do this after class. It's not a very hard experiment. So the answer is you're going to see many dots. And usually kids have good enough eyes where they can see about 13 dots that come off of here. Why is that? It's because there's so many prisms stacked on top of each other. It's got all these prisms that are taking that incoming light and shattering it and splitting it into all those different dots. The center dot is going to be focused, is going to be the most intense, most brightness, the highest intensity, and then the other ones will go less and less as you further spread out. Okay, you guys ready to do the experiment with the M&Ms? Let me show you something first. Okay, so actually let's do the Gummybear experiment first. So a lot of people have a lot of confusion about this, and here's how it starts. People think that when light passes through an object, somehow that object will color the light, you know, like paint colors a wall, for example. If I have pink paint and I spread it on the wall, it's now pink, right? This is actually one of the most common misconceptions that people have about light. So here's how it goes. Pay attention. Have you ever noticed, been standing next to somebody who's wearing like a neon bright colored shirt, maybe pink or green or something like that, and you stand next to them, and did you notice that you kind of look down and you're like, hey, how come I'm a little tinted? So why does that happen? You can see this if you put like an apple in bright sunlight on a like a white plate, and you can put the apple outside, the plate will have this red glow around it. Now, why is that? It's the same thing that happens if you, so why does that happen? So did the apple color the clear light from the sun? And the answer is no. It's actually really hard to understand that when you see a red apple, what's happening is most of the wavelengths that make up the white light, they get absorbed by the apple. The apple takes them all. And the only color that apple reflects is what color? What color is the apple? It's red. The apple reflects red light. It's not filtering anything. It's absorbing everything and then reflecting back red light. So when light hits something, it gets absorbed, and it can either be converted to heat or reflected back like in a mirror when you see yourself, or you can transmit light through something like a window. Okay, so right now I want you to do an experiment. Do you have a flashlight handy? I think I forgot to tell you that. If you have a flashlight, go ahead and grab, or just imagine you can do this. If you turn down the lights and you shine this flashlight right at, right at the wall, what color would you see? You'd see white, right? Now, if you shine this flashlight on something in the dark, like, suppose you got a blue pillow. Now what color do you see? It's blue, right? What happened to the light? Red, orange, yellow, green, blue, purple came here. The pillow absorbed all of it and is only reflecting back blue, right? Okay, now what if we change the light source? What if we only use a monochromatic one color light source? So if I shine a red laser onto, say, a blue pillow, what should I expect to see? That's right, that red light's going to get absorbed, and then I shouldn't see anything reflected back. Okay, and this is where the gummy bears and the M&Ms come in. You ready? So here we go. This is my clipboard with my ill-fated gummy bears. So I've got some gummy bears here. I've got a red and a green and a yellow. Now I have here, I'll just hold them up. That might be easier. If you don't have it, gummy bears, don't worry. You don't have a laser, don't worry. I'm going to do this for you so you can see it, okay? And I'm going to try it with the lights on, but I may have to turn all the studio lights off. So we'll see how this goes. Okay, red laser. Here, let me prove to you that it's red. By the way, this is a laser that has red and green on it. So I have two buttons. So this is two lasers in one. You can get these from Laser Classroom. Totally cool. They gave me one so I could show it to you guys. Okay, so I have a red laser beam on the paper. You see it? Okay, so I'm going to put a red gum here. You know, let me just turn down the lights. I think it's going to be easier to see. Give me just a second. I have actually two sets of lights. Okay. Ooh, now it's getting dark in here. Okay. So, all right. So I have a red gummy bear, and I've got a red laser, and I'm going to shine the red laser through the gummy bear. And I don't know if you can see the light on my hand is red. Okay, you see that? Okay, so the red laser, so the red light, the gummy bear is going to absorb the red light and only reflect red. Now, what happens if I push the green button on my laser? You see how normally it's green? Okay, so I'm going to put it through. Uh-oh, and look, it gets stopped. There's no light on my hand. There is now. But when it goes through the gummy bear, so the gummy bear is absorbing the green light and stopping it. Isn't that weird? Now, what if I do a green gummy bear? Where'd my green guy go? Okay, green gummy bear, green laser light. Okay, you can totally see it's on my hand, right? Okay, here's the green light, green gummy bear. What about the red? Ooh, look at that. It gets stopped. Here, if I don't put it through the gummy bear, it looks like that. If I do, let's see if I can do it completely. Isn't that cool? Okay, so you can see how, I'm going to leave the lights off. Hopefully you can see me okay. So remember, the gummy bear doesn't color the light. It's absorbing and reflecting the color that's appropriate, right? Does that make sense? Yes? No? Type it in right now if you got it. Does that make sense? Yes? Type it in so I know you guys are following me. Okay. Okay, so what does this have to do with M&Ms? Okay, so let's take a quick look here. Let me grab my slides here. Okay, so basically a packet of light. So far we've been talking about light as in one way, but a packet of light is called photons. Like you can have packets of chocolate. Those are called M&Ms. So light also comes in packets, like you'd have little pockets of chocolate. So photons are little packets of light, and the sun has zillions and zillions of photons. In total darkness, in the furthest reaches of space, there's only like a photon or two. Okay, so let me skip ahead to, oh, yep. Okay, let's just do it this way. since my lights are down. Okay, so there are these things called finger lasers, and for some reason, people call them lasers. They're not. They're flashlights that fit on your finger, and when you turn them on, they give a red LED light. So even though it's called a finger laser, just know that they're light. They're actually not lasers. Okay, so you can have these things in here, and what we're going to do is we're going to do a little experiment. And I'm going to demo this in light so you can see what I'm doing. And then your job tonight, or as soon as we're done, is to go into a completely dark room and do this experiment, because otherwise it's not going to work. Okay, make sense? Okay, so let me show you what we're going to do. First thing is you get to open your M&Ms. And by the way, keep this container because you're going to need it for our rocketry chemistry class, okay? So what we're going to do is, the idea is there are 3 colors of light. Remember we talked about paint and how paint is, whoops, I just ripped that off. How paint, you could make any color, any picture if you have which 3 colors of paint. Remember what they were? Yeah, they were red, and then they were yellow, and then they were blue. I had to think for a second. Good. If you're a physicist, though, those are not your 3 primary colors. So your 3 primary colors of your physicist, if you're a scientist, is red and green and blue. So those are your 3 colors. And these little finger light things just happen to come in red, green, and blue. So here's what you do. You get your kids. This is like a total fun time. Parents, you'll actually get time to yourself because the kids are going to be so busy with this. So here we go. What you do is you're going to put the M&Ms on a sheet of white paper, just like this. And then in a dark room, this won't work if there's other white light around. It has to be totally dark. In a dark room, you're going to shine one of these little finger lights on your M&Ms. And then you're going to take it off. And then you're going to shine green. So you got red, and then we have green, and then we have, what color is that? Blue. And you're going to do one at a time, and you're going to see if you can figure out which color M&Ms are which. Now, M&Ms aren't just red, green, and blue, right? So there's other colors in there. If you really want to make this hard, you're just going to take the red, green, and blue M&Ms at first and try that, and then add in the rest, actually, if you want to make it easier. So you're going to do a color test. And what's really cool about this is you'll really get a sense that when the red light comes in, all of a sudden, like, the blue ones go dark, and it like makes no sense. And the green ones are dark, but you can't tell the difference. So your job is to figure out without, now at the end you can see if you're right by turning them all on, because once you have red, green, and blue, what do you have? You have white light. So that's a really easy experiment you can do tonight. So let me turn on the lights because I have a few more things to tell you. Now, while I'm turning on the lights, can you guys type something in the box for me? So, by the way, if you've just jumped on, my name's Aurora with Supercharged Science. We're doing some experiments in light, which is why I turned off the studio lights. And so we're going to continue in just a second. But while I'm doing this, if you can, kids that have been in class so far, type in one thing that you thought was super cool that you just learned already, that you didn't necessarily know or you're really excited to try. Ready? And I'll be right back. Okay, there's one light. Let me get the other set of lights. Really need like a master switch is what I need. Okay. All right, so how are we doing? You guys doing good? All right, you want even more experiments. Okay, so we are going to do the holograms tomorrow because that's a whole other set, but I wanted to leave you with 2 or 3 experiments you can do right now as soon as we finish. You guys ready? Okay, we're going to go through these kind of quickly, so make sure you keep up. Okay, so if you have these at home, these are super fun, right? You can actually make a telescope with them. Did you know that? And a compound microscope. You just take 1, 2, and you look through, and you focus one, you focus the other, and you kind of look through here. Suddenly you have like a compound microscope. And if you want to know the magnification, if this is a 4x and this is like a 10x, suddenly 4 times 10 is 40. I can look with 40x magnification. Isn't that cool? That's all a compound microscope is anyway. Okay, so what are these things? Handheld microphones, handheld magnifiers, and if you run your fingers over them, there's like this bump in the middle, right? So that bump is what will take the light and spread it out. And so what's really cool about this idea is water does this naturally. Like a drop of water will kind of, if you have it on the end of your finger, it's kind of like a little tear shape, you know, it's like a bulge. You can make a drop of water turn into one of these, and that's how you make a laser microscope. You want to see how to make one? All right, so the first thing you do is get rid of your M&Ms. No, don't eat them yet. I didn't quite mean get rid that way. So the first thing you're going to need, now I know I didn't tell you to get a paper clip, but you're going to need one. Okay, just watch first, don't do it. What you're going to do is you're going to take a paper clip and kind of bend it in a way that when we rubber band it to the end of your, let's see if we can do this. We rubber band it to the end of your, can I finish my sentence? Yes, I think I can. To the end of your laser pointer. Okay, so it's kind of like a piece of wire, and I've made a little loop on the end. And that loop is, I'm going to dip it in water, and that I'm going to have a little water bulge on the end there. It's not going to be a flat sheet of water. It's going to be a little round, just like a teeny tiny one of these. Now I'm going to strap this thing, before I actually get it wet, to my laser pointer. And you just kind of wrap it around, and you wrap it around a few more times, just so it doesn't move. It's not very picky. Okay, we're going to wrap it around. Okay, and wait, don't do it yet, just watch me. Watch me struggle with this. Okay, and then what you're going to do is you're going to push the button, and you're going to angle this little thing so that the laser light goes right through this little loop on the end here. Okay, and you can kind of put your hand up to kind of get it just right until the laser goes all the way through the loop. And then you dip the loop in water. Don't dip the laser in the water, dip it in water. Water that you know has some goodies in it. This could be from the dog dish. Maybe you've got some pond scum somewhere. Dip it in there and then turn off the lights. Put the laser on so the laser is shining through that loop, and it will spread out the light like we talked about with this. It'll spread out the light, and you project it on the wall. You'll be able to see things on your projected image. Watch, like this. Okay, so notice I've got a laser light. You can use red. If you have a green one, that's fine. And see how I made a loop at the end, and I've attached it to my laser pointer. I've got the laser shining through the loop, and this is actually just a drop of pond water. And now, instead of being projected here, I'm going to lift it up and project it to the wall, and you can see things swimming around it inside. You'll see critters in there because this beam is going to diverge and spread out. And it's basically like shadow puppets on the wall, but they're in their liquid environment. This is really cool because normally you have to kill these critters in order to see them in a microscope on a slide, which is okay, but you can't observe how they move around and interact in their natural environment. Now, how hard is this project to do? Not hard at all, right? Here are the steps. You bend the paperclip into a shape that'll work. It doesn't have to be exactly this shape. You just attach it with a rubber band. You bend it so the light will go through the loop. And then you dip the loop, not the laser, in something you think there might be things in and project it onto a wall. That's it. Isn't that cool? So that's called a laser microscope. You can take a screenshot of this if you want to leave this slide up. Okay. And so how easy was that? Yeah, like super easy, right? There's a lot of super cool experiments that you can do with lasers. Here's another one. You guys ready for another one? Okay, so how many kids like to take a bath? Yeah, it's like half and half, right? Okay, so I'm going to give you 2 more experiments, both of which use the bathroom. That didn't come out right. Both of you, it's use a room in your house where there's running water and no lights, usually, and lots of mirrors. Okay, so most people, that's going to be in the bathroom. So here we go. What do we do? So basically, the idea is that, so when you have a light, here, let me take this off. Okay. So light likes to bounce on things like mirrors and stuff, right? It likes to bounce and reflect and so forth. So fiber optics is one application of the idea of what we call total internal reflection. Now, I'm going to show you a quick little video, and what this is a picture of is a soda bottle with a green laser shining on the outside, and it's going through. You'll see a line of light, and then he punched a hole in the side, and you'll see the laser beam will actually bend because it's it's staying contained within the stream of water. So we call that total internal reflection, which means the light is hitting the boundary where the water. So you have a stream of water, and if we shine a laser light, it'll actually stay in the column of water because it's reflecting. A little bit passes through, but most of it will just go bing, 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 and that's what fiber optics are all about. So watch this. Check this out. Let's see if I can play this. So this is the green laser, and do you see as the water level is coming down, obviously the water he has to move the bowl to keep it going. You see that? Isn't that cool? So you can actually bend light, but the point is the laser light, which is normally straight, is curving because it's staying contained within the stream of water. There are lots and lots of ways to do this. You have a bathtub, right? Next time you're in the bathroom, don't get the laser wet, but you can put it through a column of water and see the same effect. Normally laser, this is the point. You know, the laser pointer, the point where it's supposed to be straight from the laser, it's on his hand, which is not up here. Isn't that cool? So this is what we call total internal reflection, and that's what fiber optics are all about. So this is bending light. Isn't that cool? So how hard is this experiment to do at home? Yeah, easy, right? So if you want to do this at home, notice that where they're standing and where they are pointing their laser in the water bottle. You just can't stand next to the stream and shine your laser beam through the stream. It has to pass through the stream first without bouncing. So you have to start from light behind it and go to where the laser light goes from water to air, and then it's got to bounce inside. So you can really, really play with that. Isn't that cool? Okay, I've got one more for you. And then we're going to have to stop because I've been talking for like 30 minutes. So we have to do part 2 tomorrow. So for those of you who understand the idea that laser is just one color, check this out. Now I'm not going to talk about this one now because it's a little strange, but you can get a rainbow out of a green laser using the idea of fluorescence. So I've got a laser beam here, and that light is being split, which I took a picture of it over here, and I actually get a rainbow out of a green laser. If you want to know how to do that experiment, you can, I have a whole video on it because it's a little bit longer. You can download that. You can go to my website, www.superchargedscience.com/lasers. Normally, this laser, it's 5 experiments, and normally it sells for $30. I'm actually giving it to you for free. Just go to my website, www.superchargedscience.com/lasers. That experiment is in there, as well as 4 more that have to do with lasers that we didn't actually get to. Okay, so you can, if somebody can type that in the comment box, that would be really, really helpful. So it's superchargedscience.com/lasers. Lasers is plural, Lasers. Light amplification by stimulated emission of radiation, S. So lasers. Superchargedscience.com/lasers. That would be really, really helpful. Thank you, thank you, thank you. Okay, so last experiment. You guys ready? This is my personal favorite. I absolutely love this experiment. So how many of you have parents that maybe they're looking a little tired right now? Any parents that could really use a break and okay, so you have those. Great. Here's what you do. You're going to get major kid points for this one, kids, and you'll get to do your science project at the same time. So have you ever noticed how you don't actually see the red laser beam? Yeah, you can't actually see it. And if it was dark enough, you would actually see the beam for green. It's just so much other light right now, you can't see it. But you've seen like green laser beams, right? You can actually see the beam. The reason that is because your eyes are tuned for green. And what does that mean? That means that the red beam is really there, but if you had snake eyeballs that are tuned more in the red and infrared, you would be able to see a beam that comes from the laser to my hand. You can make it visible though, and the way you do that is because you want to get particles in there. Now there's an icky way to do this and a clean way, and the clean way is a total way to earn points with your parents. But let me tell you the icky way first, right? So what you do is you need a lot of particles. Now, where is there a lot of particles? Well, is there a place in your house that maybe your mom hasn't vacuumed in a while? Like under your bed? Okay, think of a place. What you do is tonight, after they say, okay, good night, and you say good night, all right, and they think you're asleep. What you do is you get your red laser and you go under your bed. Imagine there's a rug under it that hasn't been vacuumed in a while. And you go under your bed, everything's dark, the lights are off, the shades are closed, and you go under there and you go, bang, 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 bang. What happens? All the dust floats up, right? Then you shine your red laser beam and you could totally see it and do your experiments. Okay, that's the gross way. So what's the cooler way, the nicer way? You want to know that one? I can imagine the comments right now. I'm not looking at them, but I'm imagining a lot of people saying, ew! Okay, here's the much better way to do it. Okay, So you go to your mom and you say, hey, mom, you've been working real hard. I know you really need a break. Tell you what, I really need some help. And she's going to go, okay, what? You say, okay, mom, here's what you do. I need you to take a shower right now, a really hot shower. Use all the hot water. The only thing is just let me know when you're done. And mom's like, really? You're like, yes, please go do it. Go take a hot shower. Okay, so she goes to do that, and she's a little suspicious, but you're like, okay. You say, well, Aurora told me to say that. And she's like, oh, Aurora, okay, I trust her. So your mom takes a shower, comes out, she's okay, I'm done. You gotta race in there before all the steam is leaks out, because when you shut the door and you turn off the lights, a lot of bathrooms don't have very big windows. Even if they do, like, shut them off. And so now you close the lights. What do bathrooms have a lot of? They have a lot of mirrors, right? And now you've got this fog, steam-filled room. All you need now is 80s music and a laser, and you have an instant laser party. And mom feels great and refreshed. You can spend the next 20 to 30 minutes in there doing the experiments like we talked about with the M&Ms and the gummy bears. You can bring some CDs in there. If you have some plastic pieces, you can bring magnifying lenses in. If you have plastic pieces in there, like like acrylic things, and you can shine through there, you can totally have a blast. You can have a laser dance party in your bathroom, and it'll be totally fun and educational. And I would love to see pictures of what you've done and hear about what you've done. You can send them to me, Aurora@superchargedscience.com. Do you remember that picture I showed you way in the beginning? That's exactly what we did, only we didn't have a bathroom quite that big. So we handed out mirrors to people, and we handed out different things, and this is exactly what we did. We fogged up a huge gymnasium. We armed the kids with 1 to 2 lasers each, and we gave them similar information that I gave you. They just, well, actually the same information, and they had a dance party. You can actually see me there, and I'm clapping because we've got that 80s music cranked, and we are having a total blast. So how was that for your lesson for today? Was that, I know we went a little over time. I'm sorry. There's a lot in there. If you want the additional laser experiments that I mentioned, you want to go to www.superchargedscience.com/lasers. So superchargedscience.com/lasers, and you will be able to get the, oh, there it is, superchargedscience.com. I should probably change this slide to one that doesn't have words on it. Let me try that one. superchargedscience.com/lasers, and that will give you 5 additional laser projects to do, including that one on fluorescence where you can get a rainbow out of a laser, which sounds really, really strange. Okay. We also covered laser microscopes. We covered the colors of light, reflection. We talked a little bit, just brushed on refraction and so forth. So we did a ton of things. So if you know of anybody that would love this kind of learning in their house, I mean, what did we use? We used like M&Ms and regular stuff. And if you have these, oh, I forgot to tell you what to use if you don't have these. So what you get is your mom's nail polish or your sister's, and if they've got red, green, and blue, what you do is you take a flashlight and you put tape over the end so you're not painting on your flashlight, and you get 3. If you have 3 like dollar store flashlights, you put some clear tape on the end, and then you put the nail polish on. It usually takes like 2 or 3 coats, and now you've got a red laser, a green laser, and a blue laser. Laser. Did I just say laser? I'm sorry. You've got a red flashlight, a green flashlight, and a blue flashlight. So you've got a homemade version of these little guys. So it's the same thing. Okay, so hopefully that will get your kids excited and interested. I've given you a couple of hours worth of content, especially if you go and get that download that I mentioned. Again, normally it's for sale, but I'm just going to give it to you so you have something to do with your kids. It also has written explanations in there, and there's like a whole download in there as well. So when you go to that superchargedscience.com/lasers page, just enter in your email address and tell me where to send it, and I'll just send it right to you. Now, if you have any specific questions, you can. Let me tell you briefly what's coming up. Tomorrow we have part 2. We're going to continue where we left off today, and we're going to make holograms tomorrow. So you're going to need your, this guy. Where is it? Salad bin. You're going to need a salad bin, and I will post a template so you can have that as well. We'll talk about illusions and Pepper's Ghost, and we'll talk, I'll answer more questions as they come in that came in from Light from today, because there seems to be a lot of them. I'm already seeing my email is like 200 emails since I started, so I'm not going to answer questions right now. I'm going to look through those and then answer them on class tomorrow. So tomorrow's class is the same time, 10 o'clock Pacific, and if you know of anybody, just share this information with with them. On Saturday, I haven't posted this yet, but Saturday starts our week of astronomy, which continues through next week. So this week we talked about physics, and we talked about mechanics of motion, and we did projectile motion, rocketry, stuff like that. And next week we are going to apply the physics of light into a scientific field, which is astronomy. So if you love the idea of stargazing, you love the idea of telescopes and binoculars, and you want to know about what's the sun made out of and all of that, we're actually going to make a comet. And we are not going to make an art project where it's a foam ball with glitter and you hang it from the ceiling and call it a comet. That's an art project that's masquerading as a science project. We're not doing that. We're going to use real chemistry. We are going to make some frozen gases with some organics and silicates, and we are going to actually make a comet that if you do it right, it will have a tail. So that is next week. Now again, if you don't have any materials, all you need to do is just take a piece of paper and write down your ideas as we're doing experiments, so when we're done, you can know what you need to get and how we're going to use it and what your great ideas are. So next week it marks the beginning of astronomy. I will be posting the materials list shortly to Facebook. Probably later today or early tomorrow. And so you'll have the materials for next week. We will start with a virtual stargazing party. So I will be walking you step by step how to read star charts, and we'll start that on, it'll be on Saturday in the, at 5 o'clock. In PM, so like dinner time, because it's really hard to see the stars at like 10 a.m. So we're going to do it in the evening. That way, for most of the time zones in the United States, it will be right at dusk. And so when we're done, you can zoom outside and take a look at stuff. And so I will be taking you on a virtual tour of the stars, and we'll be doing planets, and we'll talk about black holes, because usually that's very popular. So we'll talk about that as well. If there's a subject that you really want me to talk about, we're doing astronomy because that was the most requested one last time I asked you guys. So kids, get out your typing fingers right now, and in the comments, tell me, what do you want to study? You know, you've got me for the next couple of weeks, however long this need is there, where you've got kids at home who are not in school. We are going to cover more science than you kids typically cover in a year. So we are going to really pack it in. So go ahead and kids type in, what is it that you are curious about that you would like me to present to you in a class? So we are doing astronomy because that was the #1 requested one in there. If you don't want to type it in the comments, you can send me an email, aurora@superchargedscience.com, and you can do that as well. Really easy to do. And so just let me know. Also, kids, while you're typing, if you could also, in a second comment, tell me what one thing you know from this class that you thought was so cool that you learned or you got inspired to think about. Tell me in the comments so I know what it is that you really liked, so we can do more of that for you. I don't know if you noticed, but this class is totally free. And so I'd like to present things that you want to know, you want to learn about, and what was it about today's that really caught your attention? Like, ooh, that was really cool. Because we want to do more of that for you. Parents, I hope this has been helpful to you in your kids' education. Do let me know how this is working for your family. We got a lot of great feedback from folks asking, for example, for the materials list early. I wouldn't have thought of that. So, because I have materials all over the place. And so that was a great suggestion. Thank you so much. And just let me know of how your kids are doing. You're welcome to send me photos. We don't post them. I just get to see them and get to see the look of excitement in your kids' eyes, and that's really special to me. So I hope this has been helpful. Thank you for the opportunity of being your coach and teacher and guide for this part 1 in the series. I promise next time we won't go quite so long. I know I've been on for like 45 minutes. I tend to do that. I'm sorry. But if you enjoyed it, give me a thumbs up. You can like us and follow us. That will notify you next time I'm live if you haven't already done that. And I will see you tomorrow. So I wanted to say thank you everyone so much. And if you have questions, you can always reach me at aurora@superchargedscience.com. And I look forward to seeing you next time. Thank you, everybody. Enjoy your afternoon and have fun with lasers tonight.